Alright, hello everybody. This is part 4 of our Unit 1 Scientific Foundations of Psychology, and part 4 is going to be talking about correlational studies. So, what is a correlational study, right? What does that mean? A big thing here is that we're going to be talking about when cause does not necessarily always equal effect, right? And that's what we're going to see a lot throughout correlational studies, right? So what does it mean to correlate, right? What is that talking about? Basically, the idea is when two traits coincide with one another, right? So when two things tend to they seem like they're connected, right? Now, what's really important here is that a correlation cannot determine basically causation, right? They cannot determine what variables cause this correlation. So we know that these two things go together, right? Or there's some sort of thing that seems to be connecting them, but we aren't able to determine why. Okay, and that's really, really, really important, right? And that's kind of what this little comic is showing, right? So it says, studies show that people who exercise are healthier, right? And he says that's because people who are in poor health don't exercise, right? And that's kind of like a good example of it, right? And I think we would have actual experiments that would prove that, but we know that people that are healthier tend to exercise more. Right? So it's kind of like, okay, these two things go together clearly, but is it necessarily a cause and effect? Right? And it's really important. And in the last kind of video, you should have hopefully seen that cause and effect can only be determined by an experiment. So in correlations, we're going to see a little bit different information. So here's some examples of correlation, right? So one example is that ice cream sales and murders correlate, right? You can see this line of murders here and this line of ice cream sales, right? So here's kind of where and the reason I use this is very specific, is that we're tempted when we see this information to try and connect these two pieces of information, right? We want to say that ice cream sales and murders are connected for some reason. That's kind of like a natural human instinct, right? So we look at these, but the question is, well, does ice cream sales cause murders, or do murders cause ice cream sales? Well, no, that's not necessarily true, right? And what's happening a lot of times in these correlation studies, or what can be happening, right, is there can be other factors, right, those confounding variables that can be causing this relationship to happen, right? So what's realistically most likely explain this correlation, right, could be something like the summer, right? Is that in the summer, right, May, June, July, right, it gets hotter, and so obviously we're going to buy more ice cream, right? Now, in the summer also, we do see crime rates increase, right? Now, why does that happen? I mean, we could maybe say it has to do with weather, but that might not necessarily be true. It might just be the fact that during the summer, right, there's a lot more people that aren't in, if you think about school, there's a lot more people that aren't in school during the summer, right? Or people are more out and about, right? If you live in a cold place, we don't really have this in Las Vegas, but if you lived in Wisconsin, well, during the winter, you don't go outside because it's freezing cold, right? So during the summer, everyone's out. People are out later, right? And so there's two kind of different factors. There's might be this idea of summertime, right, that connects these two, but it doesn't necessarily mean that ice cream sales and murders are connected, right? So here's some other examples, and these are all actual correlations that we can find through real things, right? So this red is the number of people who drowned by falling into a pool, right? This black line is the films Nicolas Cage appeared in, right? Now, what you notice when you look at this is it seems like these are pretty clear correlation, right? We can see a pretty good, right, connection between these two things. But the reality is are people drowning in pools causing there to be more or less Nicolas Cage movies? No. Right? Are Nicolas Cage movies causing people to drown by falling into a pool? Probably not. Right? So even though there's a correlation, does not necessarily mean that these two things are connected. Okay? Here's another example. The red line is the per capita cheese consumption, right? How much cheese we could consume per person, right? And the black line is the number of people who died by becoming tangled in their bed sheets, right? So we have, again, a very, very close correlation, right? It seems like they're basically going together. But again, right, these two things probably don't have anything to do with each other, right? This is a 94.7% correlation, very, very high correlation. But it doesn't necessarily mean that they're connected, that they cause each other, right? just because people are eating more cheese is probably not necessarily causing them to die becoming tangled in bed sheets. Okay? So again, just because there is correlation does not equal causation. Okay, so what we're going to talk about now is kind of some of the information that we're going to be getting, or why we do correlational studies. So the big thing is we're going to be looking at how do things correlate, right? What does that mean? And the first thing we have to talk about is the strength of a correlation, right? So the strength of a correlation is determined by what we call the correlation coefficient, right? And what this is a statistical measure that tells us how closely two things vary together and how well one predicts the other, right? And this is kind of a key term in how we think about correlation studies, is they kind of predict each other. They don't necessarily cause each other, but they predict each other, okay? And we see that through this kind of line. You can see, basically, if you imagine each of these little dots is a piece of data about some factor, right? As these data kind of clump up, that is, right, a higher correlation coefficient, right? -1, and then as we get to the other side, we'll see +1, right? And when it's bunched in that really good line, that's where we know, okay, there is a really high level of prediction here, right? That if this happens, we can really closely predict that this will also be happening, right? Now, as it moves towards 0, notice, everything kind of just goes all over the place, right? There's dots everywhere. It's random. That's where there's basically no correlation, right? The closer we get to 0, there's no correlation right here, right? And what that means is that you can't predict them, right? If you use this information here, you can't predict what's going on in by this other factor, okay? Now, our ranges are always going to go from +1 to -1, okay? The closer they are to 1 or -1, the stronger the correlation, okay? 0 is no correlation. 1 is a very high positive. -1 is a low negative. So, and you kind of saw that switching there. In addition to it just being, how strong it is in general, right? We also have positive correlations versus negative correlations, okay? Positive correlations go from 0 to +1, right? And it's basically showing that they are changing in the same direction, okay? So if you think about it as a graph, right? This is a perfect positive correlation. This is a correlation of 1, +1 right here, right? So as one factor goes up, the other factor goes up, right? If you can kind of think about those two lines like this, right? So as this one goes higher, so does this one, okay? So this would be an example of this would be right here, right? Notice those lines look the same. This would be a positive correlation, right? As one goes up, as we go up this way, right? So does this. Okay. On the other side, we have what's called a negative correlation. Now, negative correlations go from 0 to -1, right? -1 is going to look like this right here. Okay. Now, what we're going to see here is that there's still a high level of predictability, right? But, I guess if it's -1, still a high level of predictability, but they're going to be going in the opposite directions. So as one goes up, right, the other goes down, right? As one goes up, the other one goes down. So you can kind of see how they're going in opposite directions. Okay? So again, positive, they're going to go in the same direction. They're both going up or they're both going down. Negative, they're going in opposite directions. One goes up, one goes down. Now here's a really important piece, right? No matter what, no matter how strong the correlation is, right? Correlation does not equal causation. Ever, 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 ever. Okay? No matter what. Even if it is a perfect correlation, does not mean that there is causation there. Okay? We can only determine what causes something by doing an experiment. Okay? That's super, super important. You always want to remember that piece. Alright, again, please do a quick summary, and then you can move on to the next video.